Building a neural network model from scratch involves several fundamental steps that include defining the architecture, preparing the data, training the model, and evaluating its performance. Here's a concise guide on how to build a neural network model. Steps to build a neural network model from scratch. 1. Define the architecture. Choose network type. Decide on the type of neural network architecture based on your problem, e.g., feed-forward, convolutional, recurrent. Number of layers. Determine the number of hidden layers and neurons per layer based on the complexity of the problem and computational resources. Activation functions. Select activation functions, e.g., ReLU, Sigmoid, 10H, for each layer to introduce nonlinearity and enable the network to learn complex patterns. 2. Prepare the data. Data preprocessing. Clean and preprocess the dataset by handling missing values, scaling numerical features, and encoding categorical variables. Split data. Divide the dataset into training, validation, and test sets to train the model, tune hyperparameters, and evaluate its generalization performance, respectively. 3. Initialize parameters. Weights and biases. Initialize weights and biases for each layer using techniques like Xavier initialization or random initialization to prevent gradients from vanishing or exploding during training. 4. Forward propagation. Compute output. Implement forward propagation to compute predictions by passing input data through the network layers sequentially, applying activation functions, and generating output. 5. Compute loss. Define loss function. Choose a suitable loss function, e.g., mean squared error for regression, cross-entropy loss for classification, to quantify the difference between predicted and actual values. 6. Backpropagation. Calculate gradients. Implement backpropagation to compute gradients of the loss function with respect to weights and biases, propagating errors backward through the network. 7. Update parameters. Gradient descent. Implement an optimization algorithm, e.g., stochastic gradient descent, ADAM optimizer, to update weights and biases iteratively based on computed gradients to minimize the loss function. 8. Train the model. Iterate through epochs. Train the neural network by iterating through multiple epochs, complete passes through the training dataset, adjusting parameters to improve model performance iteratively. 9. Validate and tune hyperparameters. Monitor performance. Evaluate the model's performance on the validation set during training to detect overfitting or underfitting. Adjust hyperparameters. Tune hyperparameters, e.g., learning rate, batch size, number of epochs, based on validation performance to optimize model generalization. 10. Evaluate on test set. Assess generalization. Evaluate the final trained model on the test set to assess its ability to generalize to unseen data and provide an unbiased estimate of model performance. 11. Deployment and monitoring. Deploy model. Deploy the trained neural network model in production environments to make predictions on new incoming data. Monitor performance. Monitor model performance over time, retraining periodically with updated data or adjusting parameters to maintain accuracy and reliability. Conclusion. Building a neural network model from scratch involves understanding the architecture, preparing data, implementing forward and backward propagation, optimizing parameters, and evaluating performance. It's an iterative process that requires experimentation, tuning, and monitoring to develop an effective model capable of solving real-world problems across various domains of machine learning and artificial intelligence.